Hello everyone. In today's lecture, we will start discussing another major component of machine learning called unsupervised learning. In unsupervised learning, we do not utilize the XY pair as we do in the case of supervised learning. Let's discuss this concept in today's lecture. So as the recap, so far we have discussed concepts related to supervised learning only. In the last lecture, we focus on concepts such as hyperparameter and hyperparameter tuning. We also discussed what is the difference between binary and multi-class classification problems. We also discussed very important topic of underfitting and overfitting and how we can resolve these issues. Lastly, we also discussed what do we mean by validation set and where do we require this. In today's lecture, we will be discussing unsupervised learning, a famous task which comes under the umbrella of unsupervised learning called clustering, and then we will discuss a very important algorithm for clustering called k-means algorithm. So what is unsupervised learning? It is a learning that involves examples that do not come with predefined outputs such as class labels or even real value targets. Unlike supervised learning, where a teacher provides label data for the training, unsupervised learning operates without such guidance. In this paradigm, algorithms are required to discover the underlying structure within the unlabeled data. Now, when we say unlabeled data, it means that your data has only the X part, the set of independent variables in a way, but it does not contain the corresponding Y part, the dependent variable. It contains only, in a way, the X matrix. Now, this setup challenges algorithm to identify patterns and relationships within the data without any external guidance. By leveraging techniques like clustering or association rule mining, unsupervised learning algorithms reveal insight into the data's intrinsic organization. In clustering, so there are a few major tasks that come into the category of unsupervised learning. We have mentioned a few here. In clustering, we group similar data points together based on some similarity measure. Common clustering algorithms include k-means clustering and hierarchical clustering. In anomaly detection, we try to identify rare or unusual data points that deviate from the normal course of action. Anomaly detection techniques include isolation forest and Gaussian mixture models. Then comes association rule learning as an unsupervised learning task. It discovers interesting relationships or associations, we can say, between variables in large data sets. There is a very famous algorithm called a priori algorithm for the same. Now, apart from these three unsupervised learning tasks, there are other tasks as well, such as dimensionality reduction. The dimensionality reduction task reduces the number of features or variables in a data set while preserving important information. So, techniques like principal component analysis, PCA, TESNE, and others fall in this category of dimensionality reduction. So, let's start with the clustering technique. Clustering basically is the task of grouping a set of objects in such a way that objects in the same group are more similar to one another, but they are different from other groups, which we call clusters. There are many famous algorithms for the same, but k-means algorithm is one of the commonly used method for clustering. So if we try to understand clustering, you can think of, let's say, in a room there are many objects, and I ask you to group them on the basis of some similarity. So you can do a few things. Either you can group them on the basis of color. So maybe all the red color objects at one place, all the green color object at different place, all blue color objects form one group or cluster. So here color is the similarity measure. On the other hand, we can also group the same objects on the basis of their shapes also. So maybe we will group round shaped objects together. We will make a group of all the squared shaped objects and so on. So this process is called clustering, where individual objects are grouped together on the basis of some similarity. Let's take an example to understand the clustering process in a better way. Let's say we have this data where on the basis of number of purchases, let's say per month, and number of visits per month, we are dividing customers into three categories according to their buying potential. If somebody purchases a lot, if somebody purchases a lot in relatively less number of visits, we say that the potential of the customer is high. Similarly, you can find here also more purchases in less visits, potential is high. On the other hand, you will find less purchase in many visits, so the corresponding potential, buying potential, purchasing power of this specific customer is low. The last category that we have, so low is another category, the last category we have is the medium one. This is an example of supermarket. You can say this kind of behavior takes place in a mall also. So technically, it is a supervised learning data, more specifically classification data, because we have the number of independent variables here, and then we have the dependent variable, that is y. If we plot that, the same data, then we might get a plot like this, where this group represents the group of or class of high potential customers. Why? Because they visit less but they purchase more. On this side of the plot, you will find low potential customers because they visit a lot but buy less, and then you can say that these are medium potential customers. So this is once again a supervised learning data set. But in practical scenario, we do not usually have the corresponding label. Think about that. Who will sit in the supermarket or mall and based on the purchases and visit will assign them a label? You will be amazed to know that in many classification data sets, the labels are assigned manually by the human expert. The more real life scenario data looks like this, where we just collect this data on the basis of the entrance of the customers, and accordingly when they buy also, then we can fetch their information from their buying history as well. So here usually we have who visited what in how many visits. This data is more practical. Now if you look at here, we have x1, we have x2, but we do not have any y. As I told you earlier, usually y values or the classification label is assigned manually. Now this specific data is an unlabeled data set, Once again, let me remind you why this is unlabeled data set, because we have only x values, but we do not have any labeled data here. We do not have any corresponding y column. But even if out of this data can we fetch some useful insights, let's see. So I have this time plotted the same data set as you saw in the previous slide, and all the data points look same. That is, they are not labeled. In the previous example, we had 3 labeled data sets. So if we plot it like this, and these data points do not have any labels, can we fetch some useful information here? Yes, we can. So if you look at these groups, now we do not know their labels because the data is unlabeled. But this group here seems like there is a similarity among them, and they tend to be very closer to one another and far away from rest of the data points. The same goes here also. Once again, within the unlabeled data set, we see that these 3 points, they are very close to one another, means they have the similar behavior, and they are dissimilar from rest of the points, or you can say the rest of the groups. The same goes for these 3 points as well. Now, in the case of unsupervised learning, these groups, which are the data points within which are very similar to one another, but far away or dissimilar to the other groups, we call them clusters. So, in this specific case, we have 3 clusters or groups. So, even without unlabeled data, we can identify this kind of pattern or grouping of data points based on the similarity among them. This type of inferencing is useful in the case of supermarket example to identify which group of customers the supermarket should tell about its offers, and on which group of customers the supermarket or mall should not waste its resources. So this process of identifying groups based on similarity is called clustering, and one of the very famous algorithms for the same is called k-means clustering algorithm. It is an unsupervised learning technique. Why? Because we are dealing here with unlabeled data. First of all, it is used for clustering. And just for information, because names seem similar, k-means has nothing to do with the k nearest neighbor algorithm or KNN algorithm that we have discussed earlier. The KNN algorithm falls into the category of supervised learning, but k-means algorithm, it comes in the domain of unsupervised learning. Now let's see how this algorithm works. First of all, we have to come up or predefine the value of k. K here means how many clusters you want to create out of your given data set. So k could be 2, it means you want to group your data points into 2 clusters. If it is 3, it means you want to create 3 clusters, and so on. So until there is no movement of examples among clusters, this is what we have to do. We have to determine the location of k centroids. Once again, k is a predefined value. So we start with some points, we call them centroids, which are equal to the number of clusters we want to create. Then we calculate the distance, usually Euclidean distance, of each example from each centroid. So here the distance, mainly the Euclidean distance, tells us how similar 2 points are, or how similar this new point is to the centroid. Here the distance between the point and the centroid is less, it means they are similar in nature as they are closer to one another. And if they are far away, it means they are dissimilar in nature. Finally, we group each example on the basis of minimum distance with each centroid. And finally, we update the locations of centroid using this formula here, where C represents the new position of centroids of cluster I, Si represents the number of data points in cluster I, X here represents a data point, and the summation calculates the component-wise sum of all points in the cluster. Let's try to understand this algorithm with the help of one example. Let's say we have a data set like this, and we want to apply the k-means clustering on this data set. So as the first step, we will take two data points as the centroid. So in this specific case, we are taking k as 2, and we came up with these points randomly. We picked any two random points. We are calling them centroids. So one is blue centroid, another one is brown centroid. Now for each point, let's say this point, we will calculate the distance between this point with this cluster centroid and with this centroid. And we will see to which centroid it is nearer. Since it is nearer to the brown centroid, we will assign this point to the brown cluster. On the other hand, since this point is more close to the blue centroid, we will assign this to the blue centroid. So after first iteration, you will see that the points closer to the centroid blue will become part of blue cluster, and those points which are closer to the brown centroid, they will become part of the brown cluster. Now once again, we will update the location of centroid, which is done by taking the average of the data points. So when we take the average of the blue points, the centroid shifts somewhere from this position to this position, and as we take the average of all these points, the brown centroid shifts somewhere from this position to this new position. Now since the centroids have shifted, the alignment of the points may also shift. For example, if we now focus on this specific point, though it used to be part of the brown cluster, after updating the location of centroids, we can easily observe that it is more close to the blue centroid now rather than the brown centroid. So points may shift their centroid preference or cluster preference as well. So after second iteration, we will see that this point now belongs to the blue cluster, not to the brown cluster. And we repeat this process once again. That is, we will once again update the location of the centroid. Maybe this centroid will shift somewhere here. Similarly, we will update the location of the brown centroid. We will once again check whether now some points are more close to the new locations of the centroids, and we will keep on doing that. A time will come where no point will shift towards either centroid A or centroid B. Means once assigned, it will not change its cluster, it will not belong to some other centroid. That is called the saturation point, and at that point the algorithms must stop. Let's see that with the help of this practical example. Let's say we have this data set. Once again, it is an unsupervised data set because all we have is the x values but not the y value. We are starting the k-means algorithm where k is 2. And let's say as the initial centroid, my centroid value is 1, 1 and the second centroid location is 2, 1. We have taken the same points. If I can write the first point as 1, 1, 2, 1, 4, 3 and 5, 4. So we have considered this point and this point as the starting location of two centroids. And this is a very common approach. Rather than generating the random locations of centroids, we often select some points randomly from the same data set and we consider them as the initial centroids and then we proceed. So what we will do? So this is the location of centroid 1, this is the location of centroid 2. We will check for the first point what is the distance, Euclidean distance in this case. We are in fact calculating the squared of Euclidean distance. So we can also write like d square here. But nonetheless, we are calculating the distance of 1, 1, this point with both C1 and C2. When we do that, we will see that it is closer to C1, the distance is 0, and 1 unit away from the other cluster, that is C2. Obviously, it is more close to C1, then we will say that this specific point belongs to C1. In the second case, once again, when we will calculate the distance, it turns out that in the first case, it is 1 unit away and from C2, it is 0 units away. So we can observe that 2, 1 point is closer to cluster 2, centroid C2. That's why it will also belong to cluster C2. We check the third point, minimum is 8. So it also belongs to C2. And lastly, the last point also belongs to C2 cluster. Now we have to update the location of both the centroid C1 and C2. As you can see here, C1, there is only one point that belongs to C1, which is 1, 1. So 1, 1 itself will become the centroid. However, in the second case, there are 3 points that belong to cluster 2. So we will add their x-axis values 2 and 4 and 5 and take the average, which means divide by 3. This becomes the x coordinate because we are taking the average of all these 3 points. It represents that we are taking average of the x-axis values and we are taking the average of y-axis values. So y-axis values are 1 and 3 and 4 divided by 3, taking the average because there are 3 points. And this 11 by 3 and 8 by 3 becomes the new centroid location for C2. Now we will repeat the same process with these updated centroid locations. That is, we will check whether 1, 1 once again is closer to this C1, updated C1 or updated C2. And to whatever centroid it is more close, we will say that 1, 1 belongs to that cluster now. Then we'll do the same for the rest of the points as well. And if the assignment changes, then we'll update the locations of the centroids once again. And if the assignment does not change, in that case, we will stop because the assignment remained the same as it was in the previous iteration. So we will say that we have reached to the saturation point, and this is how k-means algorithm work. Now let's see, where do we exactly use clustering? It has many applications, but for this specific lecture, let's discuss the example of ready-made cloth grouping. Now let's say a new company is setting up its base in a new country, and it wants to decide the sizes of the garments. That is, if this clothing company is, let's say, making t-shirts, then it has to decide what should be the length and width of the size small, what should be the size of the of group M, what should be the size of length and width of size L, XL, and so on. And you might observe that for one brand, the dimension of, let's say, medium group differ from the medium group of other brands. That happens. Even when we travel across countries, you will find that the medium size that works in one country is very different from the medium size of some other country, because people tend to be shorter or taller in that specific country. That's why the definition of medium might change. So what these companies usually do? What they do is they try to gather as much information as they can about the garment's dimension, including what should be the length of, let's say, the t-shirt, what should be the width of the t-shirt, what should be the shoulder size, what should be the sleeve size, and so on. Here we are considering only two dimensions of the garment, let's say t-shirt in this case, length and width, and let's say they come up with this data. Let's say they go to the tailors of different cities, major cities, and they collect data from there, and they get this data. So some people, they need really high, very big garments, high length, high width, and some people require very low length and width, because any country is a diverse country and it might have people of different statures. Once collected this data, now that company should apply the clustering algorithm on that, depending upon how many groups it wants to create. Let's say that company wants to create 3 groups. In this case, if it is applying k-means clustering, it should start with k being 3 and start applying the k-means algorithm. They might come up with these 3 clusters. This cluster might represent the group of all the small people, medium-sized people, and the people who wear larger clothes. Then the size of M for that company might be the average of all these points, the centroid of cluster S, if you will, the centroid of the medium cluster, and the centroid of the large cluster. This is how they can decide what should be the size of the smaller group, what should be the size of medium group garment, and what should be the size of larger group garment. In some other specific case, if they want to create 4 groups, medium, small, medium, large, and extra large, in that case they can apply the clustering algorithm with k being 4. So clustering has a very useful application in many domains, and ready-made cloth grouping is just one example for the same. For clustering also, we have performance measures. To evaluate the quality of the clusters created, by any algorithm is called the clustering performance measures. They primarily work on these two criteria: how close the points are within the cluster, it is called cluster cohesion, and how far away the points are from the points of other clusters. This concept is called cluster separation. There are a few coefficients or metrics for the same. One of them is called Stillard coefficient. What it does, it tries to measure how similar a point is to its own cluster, that is cluster cohesion, with comparison to the other cluster, that is called cluster separation. Its value ranges from -1 to 1, the way it is calculated, and the higher value of this coefficient represents a better cluster formation. So in summary, clustering is an important unsupervised learning task. K-means clustering groups the points based on the similarity among them, and here the parameter K plays an important role, that is how many clusters you want to create. Now let's see the Python implementation of K-means clustering. Implementing K-means clustering is very straightforward using Python libraries. So as you can see on your screen, I have already mounted my drive that contains the data. Let me import the necessary libraries. Now as you can see here in the sklearn library, we have the K-means clustering algorithm available. Let me first fetch the data from my drive. Let's see the data first. So this data contains the length and width of certain concept. It contains a total of 150 rows and 2 columns, length and width. Once again, it is an unsupervised data, so we do not have any associated while or dependent variable here. Now let's say we want to create 3 clusters out of that data. So we will first create an instance of K-means clustering algorithm, and then we will fit the available data to the function fit_predict. It will give us the cluster labels. Let's see that. So once we have done it, the next point is how the cluster labels are created, and let's see them visually. So when we run this, then you see that this is our cluster formation using K-means clustering algorithm. In this specific case, since K was 3, it has created 3 clusters out of the given data, and the red cross here, the centroid of a specific cluster. So this is for the blue cluster, this is for the yellow cluster, and the top one is for the black cluster. So using these very simple steps, we can create the clusters of the given data set. So this is all about the implementation of K-means clustering. Thank you.